Linear equations in two variables. In this video, all we're doing is determining whether or not a given equation is linear. So whenever you are looking at equations, if you can put the equation in this form, then the equation is considered to be linear. This is the standard form for the equation of a line, a straight line. You have two variables, x and y, and then you have two coefficients, a and b, with a constant c. So let's see if we can put this equation in that form. Let's go ahead and distribute the negative. Okay, now we need to get the constant on the right and x and y on the left. So I'll try to do all of that in one step. I'm going to add 3 to both sides. I'm going to subtract this 2x from both sides and subtract y from both sides. So this is 0, this is 0, and this is 0. This gives us 3x plus 3y equals 1. This is in this form, so this one is linear. Okay, see if you can try this one, then start the video back up again. So if you're going to try, you should pause it now. Okay, what we want to do is distribute this -2. And try to get it in the correct form. So we need to subtract 4x from both sides. We need to combine these like terms, and we need to move the 6 over here to this side. So this is 0 and this is 0. So we'll get a -3x, and then 2y minus 2y is 0, so that's also 0, equals a -6. Well, this is almost there. You could actually go ahead and divide both sides by a -3, and you would get x is equal to 2. So the question is this a linear equation? Yes, it is. This is actually a vertical line. If you were to graph this, pardon my ugly graph here, you would go to where x equals 2 and you would draw a vertical line. So yes, this one is definitely linear. Guess I should put yes on there, huh? Okay, how about the next one? We should probably get rid of these fractions first. So we need to multiply everything by the common denominator, which is 6. If you have x over 3 times 6 over 1, 3 will go into 6 2 times, leaving you with a 2x. So when you multiply these two, you get 2x. When you multiply these two, you get 6y. And then you multiply these two. Y minus 2 over 2 times 6 over 1. 2 will go into 6 3 times, and you're left with 3 times y minus 2. Well, if you distribute that, you get 3y minus 6. So that is equal to 3y minus 6. All we need to do is move the 3y to the left. This is 0, so 2x plus 3y equals -6. This is in standard form, so this one is also linear. Okay, have a look at this one. Let's get rid of all of these parentheses, see what's going on. So we'll have 4x plus 2x plus 5 minus 2y equals, no, we don't need to distribute that, do we? But we do need to distribute this 3, so plus 6x minus 9. Let me double check. Okay, I think that's right. So we need to combine these. We need to move the 2y over here. We need to move the 6x over here. And we need to move this 5 to the right. Okay, let's see if we can do all of that in one step. This is 0. This is 0. This is 0. This is 0. So 4x plus 2x is 6x. And 6x minus 6x is 0. Interesting. Negative 9 minus 5 is negative 14. Well, that's not even true, is it? So not only is this equation not true, it has no solution. Because the coefficients for x and y are both 0. That means anything that you try to put into this equation would not work. There is no solution to this equation. So no, this one is not linear. Okay, last one like this. We need to multiply this part out right here. So we'll have 3x plus y squared equals, well, on the right, that is y minus 4 times y minus 4. So let's multiply all of this out. We'll have 3x plus y squared equals y squared minus 4y minus 4y plus 16. Okay, let's try to put this in standard form. So if we go ahead and subtract y squared from both sides and combine these, we can see a little bit of what's going on. These are both 0, so 3x is equal to negative 8y plus 16. If you add 8y to both sides, that's 0, and you get 3x plus 8y equals 16. This is in standard form, so this one is also linear.